start this recording. All right. Here we are, winter wonderland. They said it was going to snow like 25 centimeters overnight, and I was like, oh, there's no way. There's no way. Oh, yeah. Yeah. I think so. I think so. Oh, it looked like, okay, that's weird. Good. Oh gosh. Click, click, click. I need the lines. Okay. So last day we introduced a couple of concepts, but there was nothing really crazy going on in chapter 1. Just kind of an overview. And today we're going to start at the top, I guess, and work our way down, just some basic terminology. And depending on what level of stats you've taken before, it'll be ultra review or maybe not, and that's okay. I just want everyone to be starting at the same starting point. Okay. And so here, let me just, I'm guessing this is all. Let me just bring this in. Oh no, it's doing that thing where it won't let me paste it. Why does it do that? Copy. I can tell it's not doing it. How about this? Okay, I'll just write chapter 2 then. So if we have a data set, then usually we have, and I think, let me go back to, in the Excel thing that you did last week, right? You got a tiny little data set and it asks you how many variables are there and things like that, right? So you've seen it, but now imagine a spreadsheet, right? Which is usually how we store data, or some version of a spreadsheet, right? And so what we're going to talk about are variables, right? And when we analyze data, we analyze variables. And we call them variables because for each observation, right, which is typically a row in your spreadsheet, right, each observation has a different outcome, right? So the results vary by observation. Okay, so just as a quick example, hopefully it lets me do it. Okay. Oh, that's not what I meant to do. Copy. It's like it's switching between the new version and the old version on me. It's very strange. So if we have a data set that looks like this, so we've got, I don't know, Dow Jones Industrial Index companies, so stocks, I guess, or probably, I don't know, some publicly traded thing. And so we've got the company name, we've got the stock exchange symbol, the industry that they're classified in, the share price, and the volume. So in general, right, we talk about observations. So each company is an observation, and I'm gonna put it up here, or try to, each column is a variable. In this case, the observations have unique names, so that's nice. Often what we'll do is if we don't have unique names or if we have removed names from the data set, which is very common, then we add an observation number. But those, I don't count the observation number as a variable because we've just attached it for ease of reference. It doesn't do anything. And so I don't think I need to say that, but I will. We often attach observation numbers for ease of reference. But they are not variables, right? It's not information that we've drawn from those observations. It's just something that we've attached. Yeah. Okay, good. So what we're going to be doing is we're going to be analyzing these variables, right, is what we said. And so here, the company name, right, is not that interesting because they're all unique and there's nothing really that we could say about this to summarize this. Same with the symbol, right? They're all unique. So I guess you could say something like, oh, 2 of them start with A, but that's not very valuable information. But we could start to summarize things like what industry are they in, right? How many are in each industry, that kind of thing, right? And then we could talk about the share price, right? Now all of a sudden we have numbers, which means that we could do fun things like find the average share price and that kind of thing. And same thing with the volume. Okay, so what we'll notice, or what I'm going to tell you, is this type of variable. So the industry variable is what we call a categorical variable, right? Everything fits into a category. And then what can we do? Usually it's pretty boring stuff like how many are in each category, right? And so categorical variables exist and they're half of it, but usually what we're interested in are numerical variables because that's where we can do a lot of our work. Okay. And so let me just bring in from here the different types of data. Fine, let's start here, copy. How about, okay, I'm gonna just leave a little bit of space there. So when we're analyzing data, we usually only have a subset of some population, right? So part of your analysis is going to be identifying the population that you would like to talk about, right? And so what we do is we, statistics, which is the analysis part, right, is when we take a sample from a population, right, and we use sample information. So we use sample information to learn about the population. So usually kind of a main attraction is going to be the average, right? If I want to know about the population average, which we talked about last day when we were talking about inference, right? If I want to know about the population average, I really only need to take a sample and calculate the sample average and then attach some variability to that. But in general, right, we we use a sample mean. Mean is the average. Did I introduce that already? Maybe you've seen it before, maybe it's fine. But I can't remember. So we use a sample mean to learn about the population mean. What does that assume? Well, it assumes that our sample is representative of our population, right? Otherwise, we're hooped, right? If you take just a random sample, even if it's a random sample from the college, and then you're trying to generalize your results to all of Kelowna, that doesn't work. And we know that just kind of intuitively, we know that and understand that, right? And so one of the big assumptions that we're making here is assuming the sample is representative of the population. One of the main ways, or really the only way that we can do that, is by randomly sampling. So a random sample ensures that we have a sample that's representative of the population, assuming that you're pulling from an appropriate part of the population, right? And so if you're trying to generalize about all of Kelowna, then of course your random sample would have to be from all of Kelowna. And so here, how do I want to say it? A randomly selected sample is considered representative of the population. So that random sampling is very, very important, right? And we don't spend a lot of time talking about random sampling, but one of the main ways that you could do it is by, if you have, let's say, a list of people that you want to choose from, then what can you do? You can use a random number generator. And there's like competing random number generators out there. We're the most random, because can they actually be random? No, they're programmed to be random, but we're flexible, right? Excel has a built-in random number generator. It's not that great, but it works, right? So then what would you do? You would generate a list of random numbers the same length as your list, right, of people that you want to draw from, attach those numbers, those random numbers, and then what could you do? You could sort them and then pick the first 20 or 30 or whatever sample size you want, and those would be randomly selected. It's kind of a quick way to select a random sample. It assumes you have a list of the things that you want to select from, right? And so there's lots of different ways to select a random sample. Good. Now I get to say what I was about to talk about. Copy. Kind of backwards. Okay. So as we saw in our spreadsheet, right, there are generally two different types of variables. And for the most part, I only distinguish between these two, okay? There are kind of layers to each of them, but at its very core, right, distinguishing between quantitative data, so this textbook uses quantitative data, has the term, I prefer numerical because it kind of nudges me in that direction of a number and a measurement, right? And versus categorical data. So for us, I'm going to focus on any variable. And what I want to do is just highlight, right, that we said the variables are these columns, right? And so any variable is classified as either quantitative, or categorical. Category, oops, can't spell at all. Usually categorical, there. Looks wrong, but that's okay. Some other terms that we could use interchangeably would be, I prefer the link between quantitative and qualitative, or qualitative as in a quality, right? So it has some quality that you can categorize by. I do prefer categorical, right? Because it tells me that the data can be put into categories, right? Or observations are put in categories. Here, I'll make a note. Right, we could talk about the quality, but then I have to make the jump to categorical, right? So it has some quality, which I put in categories, and then all of a sudden I'm at categorical. Quantitative, on the other hand, I'm going to try to match the textbook, but I usually call it numerical, right? Because it's some number. And so here, quantitative quantity, right, is going to be some measurement or a number, right, is going to be a measurement. So some number. Not all numbers are quantitative, but it is a measurement like speed, distance, weight, that kind of thing. So what we saw, right, in our data set is we said, okay, there's not a lot that we can do with this categorical variable besides summarize how many are in each category, maybe make them percentages. That's about as fancy as we can go. But what could we do? We could then use those categories to talk about the average share price within those categories. That might be fun, right? And use it kind of to slice our data into different parts, right? That might help explain the different share prices, for example, right? But in terms of our analyses, the share price and the volume are numerical variables, right? Or quantitative variables. So I'm going to put that on here. Right. These two are quantitative or numerical, whereas we did say that the company name and the symbol are not that interesting, but they are categories, right? They're not that interesting because each observation fits into one unique category and there's nothing really to summarize there. So it's not until we get to the industry where we have kind of repeating categories that it becomes interesting. But technically, these are, categorical. So when we're first kind of starting out, a main part of our practice is going to be just figuring out what type of variable we have. And the reason for that is because the type of variable that we have dictates what we can do with it, right? What kind of analyses can we do with this thing, right? And so let's see here. The type of variable, right? So either quantitative or categorical, determines what analyses are appropriate. Hmm? Okay, I will add some stuff here. All right. For numerical, or I should try to call it what they call it, quantitative data is numerical. So we can take the average of something, right? So we can analyze the average, right, for example. And so if you're ever struggling to figure out if a variable is quantitative, then my go-to move is, well, would I be interested in the average, right? And so when I ask that, I say, well, and sometimes, you know, you could be convinced either way, and that's fine. There are those. But so to determine if a variable is quantitative, we can ask, would I be interested in the average? Right? If yes, it's quantitative. If no, it's categorical. So there are some tricky ones, right, where you could argue it either way, but I don't know. Phone numbers, right? They're numbers. Does the average phone number mean anything? No. You might get carried away and find the average phone number, but then you'd say, oh, well, what am I supposed to say about this? The average phone number is this. Well, cool, right? So for example, phone numbers are numbers, right? But we are not interested in the average. Things like first year, second year, third year, fourth year, fifth year, victory lap, right? Right, 1, 2, 3, 4, 5, potentially, right? And so I've got numbers, and this is one of those where I could be convinced either way. So then as long as you use the right argument, right, it's numerical because I want to report on the average year of college someone's in, fine, okay? For me, I think I would treat it as categorical because I would prefer to just use it as this is how the first years behave, the second years behave, third years. So I'm using them as categories, right? So there are instances, and there are many instances where you could argue it either way, right? It just depends on how you want to present the information. So another example is year of school, right? If we talk about the average year of school, I guess I could take it all the way back to grade 1, grade 2, grade 3, but here we talk about first year, second year. Oh, what year are you in? First year, second year. First year, second year, etc. Right? So we could talk about the average year of school if that's, I don't know, something that you might be interested in. In that case, it's quantitative, right? Or we could summarize data by the year of school. And in those cases, it would be quantitative, or, oh my gosh, categorical. Just depends on how you want to present your information. Okay. I feel like you'd ask questions if you had any. Time series. I've talked about time series before. When we have some sort of time variable on the x-axis, then we have a time series. Now, usually, or for us, right, we're going to have a numerical variable on the y-axis, right, some measurement. I guess it is possible to have a categorical variable, but it wouldn't be very telling. And so here, how do I write this? This is some quantitative variable, and then we have time on the x-axis. So this is what we call a time series. So over time, and we've seen graphs like these, they show them in newspapers and things, right? And what are they supposed to show? They're supposed to show kind of trends over time. And then what are we going to try to do? Well, if we're trying to look at stock prices, right? We had a dip here, 2009, and then we were on a steady increase, right? Little dips along the way, but we're increasing. So then reasonable to think that we would keep increasing, but we also understand that there's no way of knowing, right? But some terminology, we can talk about cross-sectional data, which is exactly as it sounds, kind of a cross-section at a certain point in time, right? And so time is involved, but for time series, right, then the data are collected over several time periods. Okay? Whereas cross-sectional data, everyone is observed at the same point in time. Just some terminology. Okay. Oops. Lump all these together. In terms of collecting data or kind of gathering data, we're not going to spend a lot of time there because a lot of data that we need already exists. So it's already been collected. And even if you need to go out and collect data, then that's like its own field of study, data collection and experimental design and stuff like that. And so then you learn from someone who's collected that type of data before and they tell you how they usually do it. And it should include things like randomization and just all those fun things. But data come from two different sources. So we can conduct experiments or observational studies. Okay. And so we can do experiments or observational studies. Experiments are exactly what you think they are. You control all, if not, or most, if not all of the aspects, all the variables that can contribute to a change in the response variable. So here, we first have to talk about what the variable of interest is. That's going to be your number one thing that you have to do, right? And so the variable of interest is called the response variable. And it's going to go on your y-axis. I'll put that here now because that's the thing that you're interested in, right? All the other variables are going to help you figure out what makes changes in the response variable. Right? But the main thing is to identify the response variable. And then you can talk about, okay, now I think that this variable is going to affect changes in this y or response variable. So this is in an experiment. I don't know if you guys do a lot of experiments. Do you do experiments? I'm thinking with water specifically. Pardon? Yeah. And what was your response variable? What were you interested in measuring?
The effectiveness of forming cake.
Okay. And how did you measure effectiveness?
Probably checking dosages.
Yeah, right? Yeah. Nice. Cool. Was there anything you controlled?
Dosage.
The dosage? Interesting.
Actually control everything else.
Right. Yeah, kind of an interesting experiment then. Yeah, because everything else is just kind of.
So we have to kind of try to do with all the different variables we have, different polymers.
Yeah.
Try to use same sample time, right? So that
the
sludge would be very similar to our trials.
Nice. Yeah.
But there's still obviously some variabilities as you're processing.
Isn't that the thing though, right? Yeah. Yeah. Nice. Hey, that's awesome. Yeah, I have to go pick Allison's brain about what types of, because I know you can definitely, I know you do experiments, but that's good. I'll keep that one up my sleeve. Not sure I entirely understand it yet, but that's nice. So from where I come from, right? We don't do a lot of experiments. A lot of data that we have is just observational data, right? Things where we just sit back, relax, and we just observe information. Like we observe how old people are. We observe how tall people are. We observe how fast people are driving. We observe all these things, right? And so it's just we just let the data come to us and we're not manipulating any aspect. And so I call them observational studies, make no attempt to control the variables of interest. So usually that's in the form of surveys. And so, or, you know, lots of other ways that we can collect data, but most information comes from surveys. Nice. I feel like there was something I wanted to say in here, but no, just all the data that's available. That's fine. .3 is nothing. It's a freebie. No, it's just in Excel. And so we'll do this one on Friday. I'm going to add some things. So modifying data is, I think they talk you through sorting data and stuff like that. And so we'll play around with that. And also kind of making tables and making some graphs and things like that. So I'll save that for Friday, or your Friday activity, I guess. Okay. Copy. So as we saw, categorical data is kind of the more basic data type that we have. So we'll start there and kind of get it out of the way, and then we'll move into quantitative data or numerical data. Oops. And so when we're looking at distributions from data, right, what are we looking at? We're looking for just a general summary of what this data looks like. Okay, so we're going to talk a lot about distributions, right? And it's going to be just a general summary of what the data looks like. Usually it's visually, right? But it can be numerically as well if we're talking about counts and things like that. But the distribution of the data is just, what does this thing look like? And so we'll start with categorical data. For categorical data, right? Like we said, well, there's not much we can do with that sector, whatever it was called, variable, except maybe a frequency distribution, right? And so if we kind of break down the words, then a frequency is, well, how frequently are things in each category, right? And then we look at the distribution of those counts. Okay. So if we have a data set that looks like this, here we've got, and I won't make it big, I'll just zoom in, right? So let's talk about soft drink purchases, right? Person number one bought a Coke, Diet Coke, second or third person got a Pepsi, fourth Diet Coke, blah, 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 right? And so now we want to summarize which of these were purchased, right? And so then what would we do? Well, it looks like I've got a Coca-Cola category, I've got a Diet Coke category, I've got a Pepsi, I've got a Dr. Pepper, I've got a Sprite category. And I think that's probably it, right? You'd have a category for each of the pops that you sell, right? And so sometimes you sell 0, so they wouldn't appear, but you'd want to communicate that. But in this case, let's just assume that one of, or at least one of each that you sell was sold. So what we could do, copy, is we could make a frequency distribution. I guess this is the relative frequency. What's the relative frequency? The relative frequency is relative to the others. So out of the grand total, how many bought Coca-Cola? Well, the relative frequency is 0.38, or usually we convert it to a percentage, so 38%. But I'm going to tell you that the frequency, so the frequency of Coca-Cola was, I want to say 19. And there were 50, a sample of size 50. And so we're told that N, which is the sample size, is 50. 19 out of 50, I'm going to go ahead and say is 38%. But did I bring my? I didn't. It is. Nice. So then here, right, Coca-Cola 19 out of 50 is 0.38. Nice. So usually our brains have a really hard time figuring out 19 out of 50. And so that's why we convert to the relative frequencies immediately. But you could report the raw counts, right, and compare the raw counts. But our brains deal very well with percentages, especially. Right? Let's see if this is all one piece. It is. Just so we have it. So the relative frequency is the frequency of, we'll call it the bin or the category. I think they use bin because it matches the terminology that we use for quantitative data, right? Then we talk about bins as well. And so I think that's why, but in this case, I think it makes a little bit more sense to talk about the category. Now, I feel like let me just see if I'm getting ahead of myself, or I think we can do what? So these frequencies, if we focus on these percent frequencies, which is usually how we'd report our data, we could report it in a table, right? Or as we saw in those dashboards, right? What could we do? We could make bar charts, right? Bars that represent the frequency, right? And so usually what we do, right, to visualize the distribution of a categorical variable, we often use bar charts. Right? Where each bar represents either the count or the percent frequency. Where each bar represents the raw count, if you want, or the relative or percent frequency. You've got options. The only difference between the relative frequency and the percent frequency is that the relative frequency is going to add to 1, right? Because these are proportions, whereas the percent frequencies are obviously going to add to 100. Now, you want to make sure that's the only kind of check-in point that you have is that they add to either 1 or 100, depending on which one you're using, because sometimes with rounding, right, you don't want to have something, some rounded values. It does happen where it doesn't add to 100%, because then there's always someone who's reading your report and says, where's the other 1%? So annoying. And so just be careful. And I'll do it down here. Must add to 1 or 100 respectively, but I'm not going to write that. So be careful with rounding. You might have to make some adjustments, right? Because even so, what I mean by that is when you have even if you're rounding properly, right, then it can not add to 100, right? You're rounding down consistently, potentially, right? And then it doesn't add to 100. So then you just decide which one you should round up potentially improperly, and then you're fine. Right? At the end of the day, the difference between 16 and 15%, for example, isn't going to make or break your studies, right? If it does, you probably shouldn't be rounding that much. Okay, so how about quantitative data? What if I have something like, let's see here, copy. So now we're talking about quantitative data. Now, what you would do is if you have quantitative data, now you have numbers and you have measurements, right? And so they're all potentially unique, especially if you're measuring on a continuous scale, right? Then, yeah, you could make categories if that's what you wanted to do. But often we're interested in just summarizing the numbers. And so what we do is, especially to visually summarize it, we put the data into bins, right? So same idea, but we create these kind of temporary categories, which are called bins. And so first, you're going to determine the number of non-overlapping bins, right? You've got little sections on your number line, and then you determine the width of each bin. Now, that's going to be done automatically. This is all done automatically in Excel or any software that you use, right? But you can adjust these things, right? So you can make adjustments to the bin width, for example. So I'll show you how to do that. And it can kind of change the shape of the distribution. So it's nice to play around with the bin widths, but can be adjusted. But it does give you a jumping off point, which especially in R, if you guys heard of R Studio, things like that? No. That's okay. It's a statistical programming language. It does a really good job of just picking a default, so I never make adjustments. But in Excel, you might want to kind of tweak it a little bit. And it's easy enough. So if we have data that looks like, oops, come on. Like this. So we've got some year-end audit times in days, and we've got these numerical measurements, and it looks like 1, 2, 3, 4, 5 times 1, 2, 3, 4, 20 observations. And so let's jot that down because otherwise I'll forget. N equals 20, right? My sample size is 20. And what I can do is temporarily create categories so that I can visualize these, so I can stack them up and make what we call a histogram. And let's see here, copy. So what we can do is here temporarily create categories, right, from these numerical values. So what's kind of fun about numerical data is you can turn it into a categorical variable if you want to, but unless you've saved your original data, which you should always do, right, you can't undo that, right? You can't undo from categories to numerical, but you can go from numerical data to categories. And so as long as you've kept the original data behind the scenes, then we can temporarily create categories for the numerical data. Oh gosh, quantitative. Old habits are hard to break. So if you group the 10 to 14, 15 to 19, 20 to 24, blah, 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 just making sure there's no overlap, right? Kind of classic mistake. 10 to 15, 15 to 19, right? Or 15 to 20, right? That would be a potential breakdown. But then if you have an observation, if this was 15 and this was 15, if you have an observation of 15, which bin does it go in, right? And so I've made that mistake where I made categories. I'm like, great. I think it was age categories or something, right? 0 to 18, 18 to 25. But notice the non-overlap, I counted those guys twice. And so at each transition, I counted them twice. That's bad. So it does happen, or at least to me, it does. But now I remember. All right, so you just want to make sure that they're non-overlapping. But usually what we do is we don't report numerical data like this. We could summarize it even better with an average, for example, or something like that. But to visualize it, this is what we would do. And this is all done behind the scenes anyways. Right. When you ask Excel to make a histogram, now what's really funny is up until very recently, like only a few years ago, you couldn't ask for a histogram in Excel, which is really weird because it's our go-to visualization for a numerical variable. And so that's really strange. There were ways to kind of cowboy your way through it, but now there is a histogram graph that you can insert, so that's nice. What does it do? It shows, so in this case, we're talking about the frequency, which is the raw frequency, right? The count in each bin, right? 10 to 14, 15 to 19. So we've got this continuous scale on the x-axis, and all the observations are placed into bins, and then the frequencies are increasing. Which is the same as that table that we had. Put this in. So here, this is a histogram. We use histograms to visualize the distribution of a quantitative variable. There, I did it. you're not going to see a ton of histograms on things like a dashboard, right? Because what we said was, well, I could probably summarize this with an average, for example, or even averages within categories, right? But what we want to talk about, or kind of behind the scenes, is we want to look at what the shape of this distribution is, right? And so we want to be able to describe it, and then the shape of the distribution determines what the appropriate measure of center is. So the average is a measure of center, but it's only really appropriate for certain shapes. I guess I'm holding off because I'm worried that it's later than I want it to be in the notes, but we'll see. So, okay, good. So it is where I wanted it to be. The shape of the distribution from a histogram determines the appropriate measure of center, and then later spread, but we'll start with center. So determines the appropriate measure of center if we have something that is unimodal, so one mode, the mode is the most frequently occurring value, and so one peak. So if the distribution is unimodal, so one peak and symmetric, then we can use the mean or the average. If it's not, then you're better off using a more robust statistic, such as, so if not, I'll lump all those together, right? Then we would use something like the median or other robust statistic. But before we can get there, we need to talk about the other shapes. Okay? So here are some of the shapes that we can have. So here, if I had to kind of broad strokes this thing, right, I would make it look like this, right? And so, which is kind of the same as this, just going the other way. Now, the key is to identify which direction the tail is going in, right? Because the skew is in the direction of the tail. Okay? And so the skew of a distribution is in the direction of the tail. So here, this one is skewed to the left, right? It's unimodal because it has one peak, and this is unimodal because it has one peak, but this one is skewed to the left and this one's skewed to the right. And I do find that typically, at least as we're beginning, right, that's a little bit counterintuitive because usually in a lot of different fields, we want to talk about the most frequently occurring thing. And so, well, this is where most people are, right? But in statistics, we're interested in these more extreme values. And so that's why we say it's skewed to the left and skewed to the right, right? So it's a little bit counterintuitive But as long as you remember that it's skewed in the direction of the tail, then you're okay. So then here we could have this kind of way more extreme skew. So there's different levels of skew, but we are also, oh, that wasn't very good at all. We can also have a symmetric distribution.
Oh, really late, sorry.
Quite all right.
Really?
I know, it was a tough go. So we can have a symmetric distribution. And so this is what we said, okay, for a symmetric distribution, that's when we can summarize with just the mean, right? So the mean is an appropriate measure of center. Now, the reason that the mean is not an appropriate measure of center if we think about if I've got a list of values, and then if I have a list of values, let's see here. So for example, if I have 4, 5, 6, and 7, oh, now I've done it. What's the average of those? Then the average, take your word for it. I forgot my calculator. It's in such a rush to get here. And I can't believe it. I don't go anywhere without I even brought my calculator to Hawaii. I did not need it. It's ridiculous. I'm like, oh, good. I've got it. So not having it today is really throwing me off. And so if we have an average of 5.5, that's fine, right? And so now, right, things are kind of centered around 5.5 reasonably. And so what if I change it to 4, 5, 6, and 70? Uh-oh, now I'll really need a calculator, right? What happens to the average? We don't even, oh, did you get it?
85 there, right?
Take your word for it. 22.5? So
21.25.
oh. Yeah. Yeah. I'm not even gonna try. Nice. So what happened? The average was pulled in the direction of this extreme value, right? And so as soon as we have this non-symmetric distribution, then the average is pulled in the direction of the tail, right? So here, this would be an extreme value, right? Which would generate kind of a tail in our distribution visually, right? I have to try to catch that last observation. And so here, the average or the mean, try to say them both for a little while. And there's no rhyme or reason to which term I use because it's just whatever feels right at the time. So sometimes I say mean, sometimes I say average, and often I say both, which is redundant, but that's okay. So the average is pulled in the direction of the tail, right? And so that's the reason that, okay, the only time where it's an appropriate measure of center is if it's symmetric, right? If the tails are pulling evenly, then that's fine. Then it is the center, right? Whereas if you have this tail, if you have a skewed distribution, then the average is going to be pulled away from this kind of lump down towards the tail, right? So that's a problem, but we hear it all the time, right? Things like average home prices. If you imagine home prices, would it be symmetric or maybe more skewed? Usually anything that has to do with money is skewed to the right, right? Because there's a minimum, right? And so the lowest home price, there's kind of a buy-in cost, right? And then we've got kind of these most frequently occurring prices. And then we've got very, very few homes that sell for lots and lots and lots of money, right? And so home prices is a notoriously skewed distribution, right? And so consider home prices, right? It would be skewed right. And I'm going to add here, in general, most money is skewed right. Things like salaries and selling prices and lots of money things are skewed right. You'd have to make the graph and look at it, right, to make sure. But as a jumping off point, it's typically true. So home prices are skewed right. And so we've got most prices down here. And then we've got kind of very, very few homes selling for lots and lots and lots of money. And so, but then on the radio, you hear about the average home price, right? That's something that we hear about and read about all the time, but it's not actually an appropriate measure of center. Sure, you can calculate it, right? But it's more of a measure from out here, right? Because it's being pulled in the direction of the tail. I'll put a terrible x-axis on here. There we go. Right, and so the mean, if we want to talk about that, is pulled towards the tail. I mentioned that because next time, I don't know if you listen to the radio, but there's always something where they want to talk about the average of a skewed distribution. They don't say it's a skewed distribution, but you kind of know that it's a skewed distribution. And then they want to scare you with the mean, which is something, right? And if you're comparing the averages year over year over year, then that's fine, I guess. But what's a more appropriate measure of center? We said if we have a skewed distribution, then we use what we call the median. The median is a more robust measure of center. Well, what does robust mean? Let's start there. Robust to outliers, right? It's not going to be pulled in the direction of those extreme values. So robust to extreme values, right? So if we go back to, I guess I should say what the median is first. The median is the value that splits your data in half, right? So your sorted data, you sort it from smallest to largest, or I guess if you're crazy, largest to smallest, doesn't matter. But I could never. And so smallest to largest, then you find the midpoint and that's your median, right? And so the median is the value that splits your sorted data in half. So if we have something like, I'll keep going with the 4, 5, 4, 9, 7, 8, 6. First thing I want to do is just sort these values. So I've got 4, 4, 5, 6, 7, 8, 9. All right. Then for me, of course, Excel is going to do it for you. right? But for me, just to illustrate, I use my my patent pending boop, boop, boop method, where I take my fingers and then I just boop, 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 boop my way in. Very sophisticated. And so, but it works, right? So just to show it on the screen, right? I take my boop, boop. It has to be sorted, otherwise it's not gonna work, right? But I boop, 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 boop. Right. Very sophisticated stuff, right? So here in this case, the median is 6. Now, what would happen? Imagine I change this to 900. That would affect the average for sure, right? Does it affect the median? No, right? And so that's what we mean by robust to outliers. It doesn't care about what's happening in those endpoints, right? Those are allowed to be extreme values. That's where the extreme values would be, right, in the endpoints. And so then we're just talking about the midpoint, right? And so this would not affect the median. So that's nice, right? And so the median is a more appropriate measure of center in that case, right? But it all goes back to the shape, right? The problem and the reason people don't like to use the median is because the average has all kinds of tools attached to it that we can use, right? And so whereas the median, that's kind of the end of the road, and then you're stuck and that's all you can report. And so that's why they don't like to use it as much, right? But it is more appropriate. Let's see here. Feel like I skipped that, but that's okay. I'll add those in later, but let's talk about, so the mode, I guess I don't need to do that. The mode is another measure of center, but it's not that common. Well, pun intended, I guess. What's the mode? It's the most common data point, or the most frequently occurring data point. Yeah, the most frequently occurring data point. I can never remember if it's 2 R's, so I'll just make it look occurring data point. You can have more than one, right? So it's allowed. And so can have more than one. It's not typically that useful, the mode, but we do use it to describe things like the distribution, right? The shape, we said it's unimodal because it has one peak, right? And so we talk about the modes in terms of the shape, right? And so we can have unimodal distribution. Unimodal would look something, well, here's a specific case of a unimodal distribution. We can have a bimodal distribution. Right, we've got these single peaks, 2 peaks. You can have a crazy multimodal, which is really just anything more than 2. One word of caution though, if you're finding that your data is even bimodal or multimodal, usually what's happening is you're combining 2 groups that should probably be analyzed separately. And so that's one of the kind of main things that we look at the distribution for and say, okay, well, is it possible that I've combined 2 groups, right? Maybe 2 different locations that I should be analyzing separately, right? And so that's just something to keep in mind, right? Because these look like 3 individual groups. And so then you look at your categorical variables and see if maybe you can find something, right, that would split these two groups up. If you don't have that variable, then I guess you're hooped, but usually there's something in there and you've got a good idea of why it's looking like two groups or three groups. Nice. With 2 minutes left, I don't know. The geometric mean. Fine. I'll just bring it in. It's something, so all of these you can calculate in Excel and you can just give it a data set and it'll just do it. But the geometric mean is kind of rare to use. Actually don't want that one. And I'm drawing a blank on the geometric mean. So instead of adding things up and dividing by n, you multiply things and then you take the nth root. And I'll have to look up when we use it because there are special cases when you use it, but it's pretty rare. And with that, I release you.